fans of Douglas Adams will no doubt be familiar with Marvin, the paranoid android, the depressed if slightly conceited robot from The Hitchhiker's Guide to the Galaxy. But instead of a paranoid android, how about a sassy one? A robot that rolls its eyes from time to time and fires off acerbic comments. Well, scientists from Osburg University have created just that. After programming one of their latest robots with a sense of irony. The fittingly named Irony Man is designed to be less formal and more relatable than a typical AAI. Unlike most talking machines, which speak in flat, monotonous voices, Irony Man is able to reflect real patterns of human speech. Skybot F-850 is an android astronaut, a fully automated machine designed by the Russian Space Agency for life on board the International Space Station (ISS). Engineers spent 5 years developing and preparing Skybot for the challenge of going into space. The 6-foot android is built from sturdy materials to survive the blast into zero gravity, and is specially programmed to stop it from inadvertently damaging the Space Center. Lovit was created by Japanese startup GrowthX, a small furry robot that comforts people who need a friend. Lovit is an affordable machine that heats up quickly to its owner with a pint-sized sound. For those who want a good hug, its pale skin is designed to be warm and cozy for pets, and the robot is always happy for close personal contact. Over time, Lovit's emotional bond grows stronger, and when he returns home, they begin to learn the face of its owner who comes to visit. In 2019, scientists at the Swiss Federal Institute of Technology Lausanne built a machine that allows fish and bees to talk to each other. The researchers created a robot translator that can send messages back and forth between a group of zebrafish and a swarm of honeybees. To really challenge themselves, the scientists decided to conduct their experiment from different countries. The fish were at one location, Switzerland. The bees were miles away in neighboring Austria. The robot translator issued commands to each species, then translated their responses into signals for the other group. So the fish might be shown a color or tail movement, which influenced the direction of their swimming. This would then be translated into a vibration or a change in temperature, which caused the bees to move to a different area. The bees' motion would then be translated into a signal for the fish, and so forth. In 2014, neurorobotic researchers mapped out the brain of a small ringworm, all 302 neurons, and turned it into a digital simulation. Simulating an entire brain is remarkable in itself. But the scientists decided to feed their virtual brain into a Lego robot. The Lego bot was hardly sophisticated. It had a sound sensor for a nose and 2 motors to act as its motor cortex. But with a little tweaking, the virtual worm brain was able to control the robot, driving it around a test station and stopping it from bashing into the walls. Eventually, the researchers hoped to be able to simulate not just the brain but an entire worm, building the world's first digital life form. In 2019, China began using robots to keep control of its roads. The Handan Public Security Bureau now employs 3 styles of robot that help their existing officers maintain order. The 3 robots are similar in design, but they each carry out very different functions. People in China are no strangers to robot police officers. In 2016, authorities started to use a security robot in Shenzhen Airport, and in 2017 an e-patrol sheriff was introduced in Henan. Introduced the e-patrol sheriff. Instead of years of training, what if you could get a meal after being asked to teach you to cook by a robot? Researchers at the University of Maryland are working on this. Unlike most machines, their robot, known as Julia, does not require step-by-step instructions. Instead, she learned to cook by watching videos on YouTube and copying what she saw. In this case, Julia Michael is nowhere near the star level. Her culinary skills are limited to a few basic activities. But even that is a victory. It sounds like something out of cheesy sci-fi horror movie, a robotic fish that runs on the power of blood. But in reality, a mechanized fish is no villain. In fact, it could turn out to be the future of energy-efficient robotics. Energy storage is one of the main limitations in robotic design. Most devices either run out of power very quickly or lug around heavy batteries which slow them down. In contrast, the robot fish runs on a hydraulic fluid, similar to blood inside a real fish, and receives enough power to swim upstream for 36 hours. Speed, however, is not the robot's strong point. It trudges along at a mere 1.5 body lengths per minute. Nonetheless, the robotic fish is a remarkable feat of engineering. As Professor Rob Shepard, one of the key developers at Cornell University, told journalists, "We want to take as many components in a robot and turn them into the energy system. If you have hydraulic liquids in your robot already, then you can tap into large stores of energy and give robots increased freedom to operate autonomously." In the Rwandan capital Kigali, robots are leading the fight against coronavirus. The use of mechanized practitioners at treatment centers in Gatenga and Kanyenya means staff spend less time around COVID-positive patients, and are therefore less likely to contract the disease themselves. The mass breakout of coronavirus has forced healthcare experts everywhere to think outside the box for ways to tackle the pandemic. Designed by Zorobots, the 5 robots are able to keep track of patients' vital signs, convey video messages and correct people for not wearing their masks properly. One of the androids is currently stationed at Kigali International Airport screening up to 150 people a minute. The Transformers were one of the most popular franchises of the 1980s, and one of the most terrible film series of the 2000s. Transformers, for anyone who is not aware, are autonomous robots that can transform themselves into motor vehicles. These shape-shifting wonders captured the imaginations of children over the decades. But they always seemed like a remarkable work of fiction, something that could never be created for real. Until recently, that is, now scientists at Houston Mechatronics Inc. have developed a real-life transformer, a semi-humanoid robot that can convert itself into a submarine. They named it Aquanaut. The creators wanted to build a machine that combined the freedom of a long-distance underwater vehicle with the precision of a remotely operated bot built on a $23 million budget. Aquanaut is mainly designed for use on deep-sea oil and gas pipelines. The robot begins its descent in streamlined, submarine mode, diving steadily through the water until it finds its target.